All right, 11.3 data distributions. Lots of vocab in the beginning. First thing we have here is the word mean, which I know a lot of kids don't know what mean means, but mean is simply the average. That's all it is, nothing more. Median is the middle when lined, we'll say lined up. It's lined up from smallest to greatest. Sometimes you have to take two things and add them together. Maybe you remember that. Mode is the term or the data that occurs most often. And, this happens. You can be bimodal, two modes, or you can be multimodal, which means multiple modes. So maybe you're not too familiar with that. Standard deviation is the big +1 in Algebra 2. Standard deviation is how numbers vary amongst themselves. Well, let's say amongst each other. It's kind of a new concept. It is the +1. And then we have the 5-number summary. Give me just a second. BRB. Where was I? I was at 5-number summary. 5-number summary is 5 easy, quick things to do. Includes the minimum. We're just going to do it in order. What we call quartile 1, which is the first 25%. Quartile 2, that's 50%, also known as the median. Quartile 3, 75%, and the maximum. That's your 5-number summary. Trying to think what else we might have in here that actually pertains to this. Well, we'll get to it as we get to it. There's other things here like these central spread and stuff. Shen and Dakota were asked to estimate the mean and median of the following data. Shen said the middle number value is 11. Both the mean and median are approximately 11. Dakota said most of the data are on the left. I think the mean and median will be about 9, with the mean slightly larger. So who is right? Is it Chen or Dakota? It's going to be Dakota, because Dakota's right. There is more data over here on the left. You can't just look at a histogram. By the way, this is a histogram. You can't just look at the histogram and go to the middle number and say that's the median, because this is a frequency count is what this is. And they're right. He's right. What could we do? We could go old school. We really could. Let's go ahead and type this out. We're going to use what's called class midpoints. There are about 12 6.5. 6.5 happens 12 times. I really don't want to write that. I'm just going to write 12. But there's 12 6.5s using what's called class midpoints. I'd say there's about 13 7.5s. If I look at 8.5, I'm going to say there's 23 of them. Yeah, if I look at my 9.5s, I'm going to say there's 15 of them. I'm going to say there's 9 10.5s. Probably 7 11.5s. 5 12s. 4, sorry, I should say 12.5s. 4 13.5s. What I'm doing is I'm establishing a middle value here. There's also 4 14.5s. And then I'm saying there is, let's go with 2 15.5s. So you can see here that the middle number is probably somewhere around 8.5. Let's see here. We got 12, that's 25, 48, 58, 63, 72, 79, 84, 88, 92, and then we got roughly 94 things here. So 12 and 13 is 25, 48. Okay, so it's somewhere between 8.5 and 9. And I think he's right. The mean and median will be about 9, because that's going to be towards the middle here somewhere, with the mean slightly larger. So he's saying that the average is going to be bigger than that because there is some stuff over here that's going to shift it farther to the right. All right. Which measure of center is more representative in this case, the mean or the median? Probably the median, because there's going to be more of them. Anyways, there we go. All right. Anyways, let's do what I was just talking about on this example. So we're going to find everything. And let me copy down my stuff here, because it'll save a lot of time. I need to do this anyways for the notes to make class go quicker. If I remember this lesson, it's not a hard lesson, but it just burns so much time. So my class midpoints are the 6.5s and the frequency is the 12s. I kind of got them backwards for calculator purpose here. So I'll just rewrite them. It's the same exact chart here. Class midpoint is just the halfway mark. That should be 12.5, shouldn't it? Got backwards there. All right, now there's a question over there. You remember how to do this by hand? We could write all this data out. Like there's no doubt we could do that. I just have zero desire to do it that way, so we're not going to. It's just going to burn too much time. What is up with my little text box here being all funky? There we go. Now she looks better. All right, let's continue these notes. So I went ahead and filled out the boxes here while I had it paused. You can find the median by hand by writing all the data down in increasing order, finding the middle or the average of the middle two terms. So you'd have to write down 6.5 12 times. You'd have to write down 7.5 13 times, and so forth. And it would take you a while. We're going to do this with the TI-84. We're going to go to Stat. We're going to go to Edit. We're going to put the class midpoints into list 1 and the frequency count into list 2. And it's going to do it all for us. But of course, we have to show you how, right? All right, now let's do some other cool stuff too, like show you how to draw a histogram on your TI-84, because it can do it. It really can. We can go to second Y equal. We can turn plots on. Mine are already on. Under type, though, we're going to choose the histogram. Right there she is. We'll do a zoom 9 for stat. And there's a histogram. It doesn't quite do histograms justice. You'll notice it doesn't quite look like it. It has to deal with some window settings and stuff, and it just really doesn't do them justice. Probably somewhere along the lines of steps. But it doesn't quite do them justice, but you get a histogram. You do. It's not a very good one. But it also kind of shows you the skew. This is a left skew. There's more stuff on the left as opposed to the right. But anyways, there's your histogram. Now, as far as our actual goal here is to do, we're going to go to stat, we're going to go to calc, and we're going to do 1 bar stats. Let me go ahead and write that down. Frequency list, you're going to have to tell that to L2 because that's where the frequency count is. So we're going to hit second L2 for L2 and then scroll to calculate. All right, so what did I do? I went to stats, calc, 1 variable stats, what's called 1 bar stats. Set the frequency list to be L2 and then calculate, right? Now, we do need to know what some of this stuff is because, you know, it's got notation here that you're not accustomed to seeing. Your mean is called X bar. It's the first thing you see. And it's 9.51. So I think it was Chen. Chen was pretty close. Your median, which Chen was also interested in, we'll scroll on down here. There it is, MED. Median equals 8.5. Now you can remember that he said that the mean would be somewhere around 9 with the with the median would be somewhere close to 9 with the mean being a little bigger, and he was right. He was. All right. Let's do another one of these. How can you interpret the distribution of data in a set and find the measures and center of spread? Okay. What are the mean and standard deviation of the following data set? Now this one does not have a frequency count. It's just some data. So we're just going to go to stat, edit. We're going to type it in. I don't need a list 2. I just need a list 1. You don't have to rearrange it in any particular order. And we're also going to get the standard deviation here too. The standard deviation is coming. And standard deviation, I do think, is a kind of a weird concept for kids to wrap their mind around. It's how numbers vary amongst themselves. Kind of a weird concept there. I wish I gave you a better explanation of it. Truth is, it just doesn't need one. That's what it is. Let's make sure I don't have any typos here. 4, 12, 15, 9, 14, 16, 13, 6, 7, 6, 25, 3, 13, 17, 22, 4. So, all right, we go through basically the same process. We're going to go to stat, calc, 1 bar stats. We didn't have a frequency list, so I got to clear that. I don't need that there. Calculate. And then I can grab all my data. It wants the mean. That's X bar. She's about 11.625. All right, what else do we want here? Standard deviation. That's one thing they want. Standard deviation is this guy right here, sigma x. It is for a population anyways. And she is 6.31. All right, so here we have an idea. The mean and the standard deviation are used together to measure the center and spread of the data. So what do they mean by that? The center or spread of data is simply the mean plus or minus the standard deviation. That's all it is, the mean plus or minus the standard deviation. And, you know, it's not that hard. So my center here would be my 11.625 plus or minus 6.31. And I'll have to go to a TI-84 and do those calculations. I'm just really not in the mood to be doing this morning. I take away 6.31. I get roughly 5.315. That's a lower boundary. And use parentheses here. Write it out like I would an interval. And if I take my 11.625 and I add 6.31, I'm going to get a different number, obviously. That's going to be the upper boundary. And we get 17.935. Now, in a perfect world, this is the middle 68% of all data. In a perfect world, that's the middle 68%. So 68% of the data lies between roughly 5.3 and 17.9. In a perfect world, there's not a whole lot of stuff here, so it may not apply to this one, but building up to something. All right, be right back with a 5-number summary. All right, so we're on to using the 5-number summary. And we already have everything we need. It is the minimum, which our TI-84 gives us. It tells it's 3. It is our maximum, which our TI-84 will tell us, which is 25. I'll just put that here. I actually gave my space. The median, the calculator will also tell you, is 12.5. First and third quartiles, again, in the TI-84, quartile 1 is given as 6. Quartile 3 is 15.5. And we're going to use this to draw a box and whisker plot. So our data goes from 3 all the way to what, I done forgot, 25. First quartile is 6. The mean was given as, what? The mean was not 12.5. It was 11 point something, wasn't it? 11.625. Sorry, I'm all pretty bad this morning. Third quartile was 15.5. The mean was 11.625, which is somewhere in here. We had a median of 12.5, and our mean was 11.625. Been a while since you've done a box and whisker plot, guaranteed. Guaranteed. All right, let's draw our little box here. You connect quartile 1 all the way to quartile 3. I'm going to put a little line there. That's your median. And then we're going to put a little line here. This is your mean. And they always had the arrows too, which justify the extremes. Now, this little box here represents the middle 50% of all data. That's what it represents, the middle 50%. And that's a box and whisker plot. It's also used as a good measure of the center. Pretty common use as a measure of the center, which I think we start talking about in 11.4 maybe. I don't really want to do this. Try it. I burned up so much time. And I did break this into 2 days. I thought I did. So we'll continue this lesson next Wednesday.